Okay, good morning, everyone. Just double check if anyone is not here. I would like to check the attendance quickly this time. Let me see. Let me see. So take a look. Take a look on this part.陳許廷循學家
喺度。
OK，
喺度。
Thank you。曹偉林、林俊軒
喺度。
係
喺度嘅。
stay fine。鄧家傑啊，you here？
喺度。
OK。林成漢、李佩恒
喺度。
OK。鄧俊熙、劉俊
喺度。
OK。
你好。
OK。黃奕朗、謝學明、黃俊熙
Hello。
Yes。Yep。
係。Hello。
OK。張思維、馮家謙
Hello。
馮家謙
Hello。
OK。何孝日、何禮賢
Yes。I'm here。
郭俊熙、何康力
Hi。Hello。
李晴、梁家傑
Hello。
OK。OK。李澤星、李健樂
Hello。
OK。吳漢一、魏俊滔
喺度 ，Hello。
魏俊滔 Alright。OK。Finally， 譚君佑、黃成軒
喺度。
How about 成軒
喺度。
Okay, so we would like to have a start of today's lesson. I'll go back to last topic of coverage is on covalent bond, I ask you guys to do the two clue class practice. Okay, please go back to the page. Let's check the answer first of all. It's a very quick start. It is on 8.5, is it? 8.5. This time, invite Wang Xinghin to have a start first. Can you see the screen? It is on page 124. Page 124. Did you see that page? So it's your turn to have a start. 8.5. So first of all, question 1. You're going to find out which one will have a covalent bonding, which one will not, and explain your answer. Okay, you may try to tell it all together instead of one by one. Spot for me which one would have covalent bond, and give me a reason. Covalent bond. Wang Xingyin, are you here?
I'm here.
Yeah. What do you think about question 1? Just spot D. Which one would have a covalent bond?
Hydrogen iodide.
Yeah, hydrogen iodide. Formula. You know the formula? Do you know the formula? Hydrogen iodide. Don't know.
H.
H what?
HI.
HI. Okay, so explanation part. What's the explanation?
The two atom is non-metal.
Okay, those material, both hydrogen and iodine, they are non-metal. So how would you bond it by covalent bond? So you are going to tell how the covalent bond is formed.
The positively charged nuclei of the two atoms and the negative charge share the electron.
Okay, between what is the two bonded nuclei? It's between hydrogen nuclei and iodine, right?
Yeah.
So that's one way to answer, and you may need to share as electrons, share outermost shell electrons with an iodine atom to make a molecule. Okay, first of all, please spot the nature of the element. Is it metal, non-metal, semi-metal, etc.? And then what's next is to tell me the combination of force. How it is by sharing of the. I want to address to all of you. It is by what I've said before. It's set by sharing of electrons. Sharing. Can you see that? Sharing of electrons. Sharing. Now, so similarly, you do the same tricks to answer because the way to the format of answering, they are more or less similar. So I don't want to write it one by one. Just for me another substance which is said to be having a covalent bond. Chinoka?
Yes.
Yep. Which one?
So sulfur dioxide.
Sulfur dioxide. Yes, this is for sulfur dioxide. SO2. Okay. So the reason is they are more or less similar to what to the one on the first one for hydrogen iodide. Very similar. So go back to now the structure of this would be a little bit strange, in which the sulfur here is not an octet, while you're having the bonding with O2. Why do I say so? So for sulfur, the bonding of it will be this. So you may have one lone pair electrons here. So we count the number of outermost shell electrons for sulfur now. Is it 8? The answer is no. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons. So it is a non-octet structure, but we will still have this in naturally. Okay. So just leave you a clarify of doubts for some people who just say that, Mr. Chin, is that all molecules said to be stable, having a octet? Now the answer is, some is, some would not. Especially while you deal with the period 3 elements. Period 3 elements at the center atom. Okay, so there may be an expansion of octet. Okay, can you see that term? Expansion of octet, but still the molecule is said to be quite stable. So it is another phenomenon. So octet rule only holds when you talk about for the first 2 periods, mainly. But the third period, fourth period, there may be some other cases in which there may be expansion of octet. Can you get the point? Now, so how about magnesium nitride and magnesium chloride? No, it is by what? Ionic bond. Okay, why? Because for magnesium and silver atom, it loses electrons, right? While for chloride ions and nitride ions, they would gain electrons. Okay, so you may see the word gain electrons, lose electrons. You tell it together and tell me which is which. Non-metal atom. Non-metal atom, they will gain electrons. At the same time, metal atoms lose electrons to form ionic bond. Can you get a point? So the whole case will be this. Any questions, any doubts so far? So what is the formula of the two? Do you still remember? What is the formula? Hong Ga-hien.
Here.
Yeah, tell me the formula.
Sulfur dioxide.
Oh, I've just written. How about the other two non-written part?
Okay, let me write it. Let me write it down in the chat box.
You have to get more practice.
Yeah.
Magnesium nitride and silver chloride.
Silver H
Yes, MgN3,
Cl.
correct. AgCl2.
I bet it's what? Is it?
So before you answer these questions, you have to get to know the charge of ions. So magnesium ion, it is 2 plus. Nitride is 3 minus. Silver ion is 1 plus, while chloride ion is minus. What is the formula of magnesium nitride and silver chloride respectively? Are you here?
Yes. Mg3 N2. And then silver chloride is AgCl.
Yeah, AgCl. So you may have got this. It seems that your do I need to have a quiz series again? It seems that you were some of you work so slow.
It's just thinking about the charge.
Oh, I see. Okay. Have you turned on the screen?
Yes.
You may see it. I just written.
Yes.
Now, question 2. Going along. compound.
hello.
The question 2. Take a look.
Question 2.
Atoms of element, yeah, XYZ, the atomic number 1, 16, 19 electrons respectively, and they will form different combination to form different compound. Predict whether it is the covalent or ionic compound for each compound. Now, for you may see it one by one. P and Q. Okay, P is what?
P is the covalent compound.
Yep. P is covalent compound. And what is the name? What is the name?
Name is hydrogen sulfide.
Yep, hydrogen sulfide. Name, okay? So this is
Yeah.
hydrogen sulfide. So what is the electron diagram? So what will you draw? Overlapping of circles and or the middle bracket one?
Just only show the outermost shell.
Yeah, take a look on B, right? Yeah.
Yeah.
So
Yeah, I think it's overlap.
yep, overlapping of circles. So which one is the center atom?
Sulfur.
Sulfide.
Sulfur in the middle, right? Sulfur, and with hydrogen with single bond. So in order to tell the difference, so you use dot and cross to tell. Okay, crosses they are from sulfur. Dot is from hydrogen atom. So it is a way or to tell to draw about the electron diagram for P, covalent compound. How about Q? How about Q? Can I?
Q is
yep.
It's an ionic compound.
Ionic compound. Okay, ionic compound. So the name is
Potassium hydride.
potassium
Hydride.
Take a look on Q. Q is a combination of Y and Z. Y and Z.
猜錯咗添。
Yes, potassium sulfide. So what is the formula?
K2S.
Yeah, K2S. So the way to form the sulfur, again 6 electrons, so 6 cross 6 is plus, while the 2 dots, it is from potassium ion. So we have got 2, right? Because each potassium atom would have lost 1 electrons in the outermost shell. So you have got 2 here, right? So you have to make it 2. Or somebody who love to write down plus, minus, plus is also okay. Or even the 2, one on top, one on the bottom, and then on the right hand side is sulfide ion is also okay. Questions? Just give you a start, warm up. Questions? Oh, if not, now you take a look on the dative covalent bond. Dative covalent bond. Now, dative covalent bond, what is that? And that covalent bond is very strange. It's very strange. Instead of sharing electrons, okay, covalent bond, you talk about sharing of electrons. Well, whenever you have got a bond pair, each electrons is from their own atom. But if you want, but we will have some other special case. We call that another special covalent bond, in which those bonding electrons, it is from one type of atom. So we will call that dative covalent bond. In Chinese, we call it 配位共解結. Why we say that 配位 is because of the fact that it occurs the condition of formation 構成條件啊 will be first of all an atom having a lone pair of electrons. We would say that it is a something electron rich. All of you could you please copy it down the term. electron-rich center. So this is the place where it is have got quite a rich amount of electrons. So very often, what can it be? Lone pair. Okay. So why is it lone pair? Because it is unbonded originally. So even though I would have a dative covalent bond, it doesn't affect the total number of electrons in those atoms. Okay, originally it is the number after the covalent bond is still that number. Because for the partner, they would not provide any electrons. So this is the second condition. A second particle having a vacant site. Vacant, what is that? Without somebody. We call it vacant. You maybe you go to the toilet, right? You may see the door occupied or vacant. Okay, so vacant means nobody inside. So if you use that word to describe the outermost shell, which is a vacant site, which means that one, where for that places, there are no electrons. To accept, it is placed to accept that lone pair electrons. So we call that electron deficient center. Electron deficient center. So the way to have a bonding, it is from electron-rich center to have an electron deficient center having the bonding electrons, or from the electron-rich center. Can you get a point? So of course, once you heard of those in English, it will be quite difficult to understand. Now it's time to take a look on the example. We just showed the book. We showed you two examples. One is ammonium ion. The other one is hydronium ion. Hydronium ion, as said before, it's dissolved in water to form that more stable species. Could you please let me know now among the 4 electron pairs, which one of ammonium ion, which one is it shows a dative covalent bond? Now use a highlighter to highlight it. Which one? Anyone who can tell?
Both electrons is 即係兩個都係一點嗰個，即係 dot。
Okay, both they are dots. So
Yes.
circle it, please. Thank you. Circle it. It's this one. Can you see that? This one, it is a place where it shows as a dative covalent bond. How would you present this as a dative covalent bond in reality? I would have, when I draw the bond line structure, I will show an arrow. Can you see that? The arrow means electron-rich center here to give a lone pair of electrons to electron deficient center. So that's why I use an arrow. Can you get a point? So I show from the covalent bond is a very special one. Now for the other 3, can you see that? Connected to hydrogen, all those they are just one dot and one cross. You may easily know that each atom is from their own atom in the bonding in that bond. But for the final NH bond, so you may find that they have got 2 dots in terms of 1 dot or 1 cross or double cross, right? So for this case, we would say that this one is a dative covalent bond, while the electron-rich center, where is it? Where is the electron-rich center? Could you please label it? Deng Junhei. Which one is the electron-rich center? Which is the electron-deficient center? Hi. Deng Junhei, are you here? Now go back to the definition. I'll give you some hints. So go back to the definition. The atom having a lone pair electrons, we call it electron-rich. The other atom or particle having a vacant site, we call that electron. For the incoming of the lone pair electrons, we call that electron deficient. So where? No idea. How about Cyrus?
Yes.
Which one is the electron-rich center? Which one is the electron-deficient center?
The N nitrogen the N is the electron resistance.
Electron-rich
Well,
or nitrogen atom, okay? Because it
yeah.
provides long pair electron.
To the
How about
nitrogen atom, which is electron deficient.
hydrogen atom, ion? Ion, okay? So you please get note of the difference. This time it is electron deficient center that is of hydrogen ion, not atom. Why? Because hydrogen ion, it is a place where they have 0 electrons. First shell, right? So which means we have got the we have got the vacant site, right? Vacant site for the incoming of 1 lone pair electrons, okay, to form a bond. So after bonding, hydrogen is stable, is fully occupied now. Can you get my point? So this is the hydrogen ion, not hydrogen but not hydrogen atom, which is said to be electron deficient. Confusing, right? It seems some of you got stuck here. Maybe I will give you one more examples, such that you will have an easier life. Now take a look on the second one. It is hydronium ion. Now based on the diagram, could you please spot for me again electron-rich center and electron-deficient center? Do you know the game to play now? 李佩恒 So what is said by electron-rich center? It provides something, right? Take a look on page 124.
lone pair electron.
Yep. So which atom or which species will provide lone pair electrons for bonding?
Oxygen.
Yep, oxygen atom. So remember, atom. Oxygen atom, we call that electron-rich center. Why is it electron-rich? Because it provides a lone pair electrons. Can you see that? For the bonding. This one. How about electron deficient? Yeah, good. So which one is the electron deficient center?
Hydrogen.
Hydrogen. Hydrogen what? What particle is it? What type of particle?
Ion.
Yeah, ion. So remember, you have to tell it very clearly whether or not it's an atom or an ion. So why is it electron deficient? Because it has a what? It has a vacant site for the incoming of a lone pair electrons. So you may see we have got 3 bond pair on the right hand side. You see that 3 bond pair. Which bond pair tells you a dative covalent bond?何麗賢. Which one? Who shows you we've got 3 bond pair, right? For this part, 3 bond pair.
Yes.
Which pair shows you a dative covalent bond? The one on the left, the one in the middle, or the one on the right?
The one on the right.
Yep, good. How do I know that? Because we have got the same 2 dots. Both they are dots, which means those electrons, they are from the same element, okay, which is oxygen. For those who have got difficulty, could you please put up your hand? Let me know. For those who find it easy, please put a tick. Easy to manage. You understand? You realize what is that now? Please put a tick. Anyone who got puzzle, please put up your hand. Let me know. 黃成軒、譚君柔、吳漢日日good，馬家樂、李健樂 ，What do you think？ 馮家謙、張思維，林成漢、家傑，not clear about why O is an atom. What does mean by why O is atom? O, oxygen. Oxygen itself is an atom. Now check the outermost shell electrons, the number. We have got 6 red dots. Okay, so it represents the outermost shell electrons number. So if that O here is an atom. No middle bracket, right? No charge, so it's an atom. But you may see that the oxygen here we have got 2 lone pair. So can you see for the 2 lone pair? This is 1 lone pair. This is another lone pair. Okay, can you see that? We've got another lone pair. While these lone pair electrons, what will happen? They would be, we call that an electron rich. Okay, because it is full of electrons. So while this part will find a place where it is a vacant site, or we call it an electron deficient center, which means the electron deficient, just like not enough. The electron state is not enough. Of course, hydrogen ions, the outermost shell is none of the electrons. So of course, it does not have enough electrons. So what will happen? After that combination of the 2 species, what will happen? So what can you get back to the significance, right? To how come we have got dative covalent bond? After bonding, what will happen? Both water molecule and hydrogen ions become more stable. Why do I say so? Now, originally for water itself, it doesn't need to form any bond with other materials in order to be stable, but not for hydrogen ion. Can you get my point? Because for hydrogen ion, it is just one proton containing, no others, right? So it is highly unstable. So they will find its partner in order to make it stable. Hydrogen ion, how do they want to make it stable? Is to find enough electrons to make it duplet, because you are just dealing with the first shell, not the second shell or the other, right? So that is just a perfect match to have a water molecule having oxygen atom. We have got 2 lone pair electrons unbonded, not having any bonded with any atoms, to share its own lone pair electrons to the hydrogen ions to form another more stable structure. So we call this type of very special covalent bond a dative covalent bond. Why is it so special? It's because for the normal one, what is meant by sharing? Okay, sharing, which means you give $10 and you give the other guy give $10 to buy a item which is $20. So we will call a type of equal sharing. But if you want to have a dative covalent bond, it's not that. Okay, it's not that. How? It's by what? I tell to the others. Okay, I tell the others that we try to share the money, share the cost by giving $10 each. But all in a sudden, you as a little brother tell your elder brother, okay, that I don't have any money. I will not give you. I will not share the cost. The elder brother, you say that, or you just nod his head, not his head, and try to pay on behalf of his little brother. But you tell the others, but you tell in front of the crowd that it's just a sharing of the amount to buy such. Can you get my point? So it is a very special relationship. Do you get my point? 頭嗰日你知唔知我講咩？
少少啦，我唔係明晒。
咩叫 concept immediately clear 啊？林成漢你講乜嘢啊？即係簡單啲講 ，covalent bond 咧就 AA 制，知唔知咩叫 AA 制啊？即係每人夾咁多就夾咁多啦，係咪啊？你買頭先我咪講咗話買夾個20蚊，即係冇20蚊好似好 cheap 咁啦，買個2000蚊嘅嘢係咪啊？咁你自己一個人俾2000蚊，你唔制噶嘛？你咪揾個人又肯同你俾1000蚊，每人俾1000蚊咪2000蚊咯。咁呢種咧就係叫做 covalent bond 啦，就係每人籌期嘅，每人俾一半，明唔明？大家夾2000，但係 dative covalent bond 係咩啊？即係頭先我講咗個例子啦，係咩啊？即係兩兄弟係嘛？但係好似 Cyrus 咁啊，係嘛？你細佬應該 Cyrus 你明我講咩㗎啦？啊，你同你細佬一齊想買一嚿嘢，但係你細佬冇錢，跟住你阿哥你做阿哥嘅，你係俾晒啲錢，跟住就話俾屋企人聽，其實係 AA 制嘅，咁呢個咪叫配位共價件咯。如果咧明啦嘛？係啊，但係面頭都話俾人聽係 share， 面頭都係叫 AA 制㗎，但係假嘅，真正唔係 AA 制，真正係一個人俾晒錢，另外一個乜嘢錢都唔使俾，好多錢嗰啲係咩？係邊個嚟㗎？喺呢個 case 嚟講就 oxygen atom 啦，又或者上邊嗰個咩嚟㗎 ？ammonia 嘅 hydrogen atom 嗰個咧就係最有錢嗰個嚟嘅，即係好勁啊！呢啲阿哥真係唔話得㗎啦，係嘛？同你俾晒暗打低俾晒錢，但係其實話俾人聽 AA 制咯。但係冇錢嗰啲邊個嚟嘅咧？嗰啲細佬喺邊啊？呢個 case 係hydrogen ion 啦，而下邊嗰個咧都係 hydrogen ion 咯，明唔明 ？get 到未啊？好，林勝康係明係嘛？林勝康明，咁應該8.6應該識答嘅咯。呢一個你試下。
哇，好驚喎
！Yeah. It is on 8.6. Carbon forms carbon monoxide. Indeed, it is a triple bond. For the first two bond, it is really the equal sharing. While the third bond, it is set as dative covalent bond. Who is the elder brother? Who is the elder brother with got money? Who is the younger brother with have enough money?
冇事，等我陣。
係，你心咩啦？ Also, is it good if I invite some others, right, and try to solve your thing first? Cyrus, again, that's you.
Yes.
鄭浩明。
Trying to solve the question.
Hmm?
I'm trying to solve the question. Please wait.
Which one is electron rich? Which one is electron deficient?
O is electron rich.
O is electron rich, and carbon is electron deficient.
Electron deficient.
Yep. So this one already show you how the electrons they are shared. So can you continue this part? Can you draw this? This part?
I don't have an iPad pen, so I can't.
Don't worry, but can you draw it? You may describe. How about the overlapping area first of all? Overlapping areas. So how will you represent that phase change triple bond? Originally, the purely triple bond of equal sharing is just three pairs. Okay, three pairs of dot and cross. So how about this triple bond?
The oxygen atom will share 3 electrons, not 4 electrons with the carbon atom.
Okay, 4. So how would you show it? Just like this one. And let me see. So this is, for example, cross like this. Okay. So we have got dot here. How about the carbon? Carbon is belong to group 4, so we have got 2 dots here as a lone pair. How about oxygen? How many lone pairs are there?
Also 1 pair, so 2 electrons.
One lone pair electrons.
Yeah, one lone pair on each. Okay, remember, 1 lone pair on each. So you may get to know it is dative covalent bond. Show me where is the dative covalent bond on here. I show it on the top most. How about the electron diagram? This time it is the bottommost, which shows a dative covalent bond. So don't worry about the position. Okay, this part, this, it represents the same thing. So don't worry. Do you mean that Mr. Chin, this one is wrong? I should write here such as it is right. Both are correct. Okay, as long as the chemist, you read the electron diagram, you will use the crosses to tell me we have got a pair of crosses. I know it is from the same metal. So you already tell me it is a dative covalent bond. But once I see the overlapping circle, I just see 1 dot and 1 cross. What is the meaning? It is just a normal covalent bond, but not dative covalent bond. Understood? Is that clear?
Mr. Chin,
Yeah.
I would like to ask what is H4O?
H4O.
Yes.
Where do you see it?
No, because I think if we can have
H4O?
dative covalent, yes. No, I just asked.
Do they have sub? You mean?
Yes, if have or not.
Oh, now go back to this. We will got H3O plus. Okay, can we have H4O2 plus? Right? Do you mean that? But
Yes.
now the reality, right? What is the reality? The reality is that this substance will not easily happen because for each hydrogen ion to be formed, it is already a very unstable species. So once an incoming of the 2 that reactive species which are both carrying the same charge, okay, before merging with 1 water molecule to form a materials is already repelled. Okay, and second, and the charge it is much higher than the original substance, in which we will make that material more unstable. So what you just suggested, from theoretically, it is not so possible, it's not so stable. And in reality, what you just suggested here cannot be found so far. So the answer is no. We still haven't got this in the world. Now, how about the others? It seems many of you have got may have difficulty in drawing the electron diagram, isn't it? It seems that many of you feel puzzled, feel quite uneasy right while you heard of us. Don't worry, for this part, skip it for the time being. We'll go back to this later when we have calculations. So we just go to do some MC questions to make an end. Try to get to know what you know about covalent bond. Remember, first of all, covalent bond, if you talk about sharing of the electrons, it's a normal covalent bond. While covalent bond, what is that? According to definition, this is an electrostatic force of attraction, something directional. Why? Because that positively charged, it is from the nuclei, the plural of the nucleus, right, of the 2 bonded atoms, and the negative charge shared electrons, which is the bond pair. And normally, we would have the combination of atoms of non-metals to form a covalent substances. if you have the atoms of non-metal which are the same element, they will form elements. Okay, so the elements normally it is in form of molecules, but of course some of them they are of giant structure. You have got the combination of different non-metal atoms that bond together by covalent bond. We got a covalent compound. So that's why you may see the following. On these 4 examples, they are just covalent bond. They will hold it as an element. It is still an element, but you have got covalent bond. Okay, why? Because you may find from the color of the boards, they are just making of the same color, right? While you have such, it is an element made up of non-metal, same type of non-metal atom. How about this? Different color of boards, right? So we will have it as compound. Compound. All those they are just compound. So we focus on the sharing of the electrons. So no matter which one you are going to have, even though you talk about the same element or different element, in order for the readers to get to know which is which, we usually, can you see that? We usually use dot and cross to distinguish the different atoms, even though they belong to the same element. We use dot and cross. Can you see that? We use dot and cross, 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 right? Until we see one case which is said to be a dative covalent bond. So you may see this part, we've got a double dot or double cross. In this case, it is a double dot, right? To represent that covalent bond, it is not an equal sharing. It's the bonding electrons is contributed by one atom only, while the others, they just accept, no need to share. So we will call that a very special relationship, dative covalent bond. All right. So this is the core concept of this chapter. Okay, I will invite people on the list. We need to be a little bit tense, right? We've got from question 2 to 17. I will choose 15 students on the list to tell me the answers. Right? For those who haven't answered anything, be prepared. Chen Huiting, question 2. A molecule is A, B, C, or D?
B.
Hmm?
The answer is B.
B. Okay, an atom formed by covalent bond. Yes, that's right. 分子 molecule, 分子 a single unit, having a combination of atoms bonded by covalent bond. 何偉林
Hi.
Also, what is the answer? Someone suggested C. How about you, 何偉林? So what is that? X is hydrogen. How about Y? Somebody says B. Now take a look why. Why was that? With the electronic configurations 2, 8, 4 silicon. So the answer is B. Correct? Quite the opposite. It's not B. Which one is the center atom? It's silicon. So this is Si, H, 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 and H. So the answer is D. Can you get my point? The answer is D. For one hydrogen atom, they just they can be stable by having one single bond. But for silicon, we need 4 single bonds. So silicon atom is a center atom. Ronald, number 4. Now, very often DSC type question is very strange, right? They do not tell you dot and cross. All those they are dot and ask you to guess. Question 4. Now you may have a guess on Y. Which group does Y belong to? Which Y? Take a look on Y. You may see having an overlapping circle with X. So take a look on the overlapping areas. How many electrons are there? What is the bond pair? Is it single bond, double bond, or triple bond?
Double bond.
It's double bond. Double bond, how many electrons should be there for the double bond? How about single bond?
At where?
I just circle it. Y and X. Can you see that?
Oh,
Y
two.
and X.
Yeah,
There's two electrons, so it is a single bond instead. It's not double bond. It's single bond. It's single bond. So single bond. So if you have got single bond, which means each atom. So what will happen to form such a single bond? Share how many electrons?
They share. They share
one or two.
They share 2 electrons.
3.
2.
2.
They
each atom. Each atom.
1. They share 1.
1. Okay, just 1. So remember, after having this, you may judge. This we have got this atom. It is from Y. For the other is from X. So you may count it for the lone pair electrons. Okay, so how many outermost shell electrons are there in the free atom for Y? So altogether we have got 7. So Y it is group 7. Can you get a point? So can you make a difference, right? Altogether we've got 7 electrons in the outermost shell for Y. I don't need to mention that. So you do the same, right? This one is from Y, this one is from Y. So how about the remaining X? How many electrons should be there in the outermost shell? It is 1,
5.
Yep, 2, 3, 4, and 5. Which means X is group 5. Can you get a point? So which one is the best combination?
D.
Yep, the phosphorus chlorine. We call that. How would we call it? What's the name of this? Phosphorus. Do you know the name of this?
Chloride.
Trichloride.
Oh, sorry.
How many? Why you say they tri? We have got 3 chlorine atoms. So we call that trichloride. Okay, is that clear? I'll give you one more chance, Lei Cheng. Question 5. What do you think? Elements X and Y form a covalent compound with a chemical formula XY2. Which of the following combinations about X and Y is correct? XY2. So if I write down XY2, which one should be highly likely to be the center atom? XY2. Which one is it? Central atom. So what can it be? X or Y? It is X. So very often, while you talk about the one being a central atom, so what is the characteristic? Which group does it usually belong to?
It's a metal. Or I think the answer is D.
It's D. D?
Because magnesium is 2+, and fluorine is very organized by ideas.
Covalent compound.
Yes, that is something tricky. Very tricky question, right? So if you just stick back to the formula to tell, you may have this one also could be considered, right? But I would say it as a covalent compound. So the way to make a bond is by sharing of electrons. How about magnesium and fluorine? Magnesium atom, they have 2 more electrons. So they tend to lose electrons, right? So the method of the way to make a bond is by ionic bond. So for D, cannot be chosen. It's rather tricky because they from the formula they show you as MgF2, very similar to the answer XY2, right? But it is not covalent. It's ionic. So Wang Yilong, tell me what do you think about the answer?
The answer is A.
A. The formula is CS2. Okay. CS2. Got it? It seems many of you may have puzzled about this. Okay, so we try to do more questions before the end of the lecture. For the remaining parts, I would urge you guys to do it by yourself. Now, because we only have got 2 more minutes to go. Zhang Siwei, are you here? Question 6.
Yes.
What do you think? Does not form a covalent bond. Take a look at the word not. So what makes the nature in forming covalent bond is by sharing of electrons. So what's the ultimate goal after sharing of electrons? They want to make the atom itself stable. What does it mean by stable? The outermost share electrons number would attain mostly 8, right? Or duplet for first share. Yeah.
B.
So it's B. Yes, that's right. B, because this is lithium, right? So
Yeah,
even
metal.
after I share that electrons, right, they will never obtain contact. Only by losing electrons will they obtain a duplet structure. Is more stable one. 粒電子佢嗰個結構咧變 lithium ion 啦 ，lithium ion 咧反而 stable 啲啦，係嘛？但係 sharing 嘅話咧，佢明明得一粒，將來電子層一粒電子一 share 埋，仲多咗添2粒，但係第2層我要8啊嘛，咁所以咧唔得啦。It's a metal first of all, right? So this is B. Could you guys get the point? Now take a look on question 7 to 17. Now you better do it by yourself. Question 17 to 17 to 7, right? And as well as some basic questions about the forming of the formula, right? Okay, so you take a look, circle it. It is question 18, question 19, and question 20. Question 23. Okay, it is more miscellaneous question, right? It comes 24 lastly. 24 lastly. So it is somewhat basic. So I would urge you guys, right, if you have still got stuck in making the covalent bond or even being confused by ionic bond as well, okay, so you do those questions, okay, at home. So the answer has already given into the ebook, right? Do you know that we have got the ebook in the Google Classroom of another class? The one commonly shared by Chem 1 and Chem 2. We have got the other one. So Mr. Wong has posted it a long time ago. So here, once you click that, go to chapter 8, and you may see the answer there. So this time I don't want to check with all of you, instead you have to do it. Okay? Or maybe I don't want to trust you, right? So you better do it as a homework. my second thought. It seems that after today's lesson, chemistry lesson, you just throw them away. You better do it. And I would like to check the answers. Okay, for those questions. Do you know where is it? Follow MC. It is from question 7 to question 17. And then for the long questions, it is from it is 18, 19, 20, 23, and 24. Okay. I do hope this will help you better understand and better have a better preparation before we come to the is it the final? Is it the final online lesson? That should be next Monday. Is it? Next Monday. This is a final face-to-face the online lecture. So we would get to know what is meant by the simple molecular structure next lesson. Go home and please take a look on this chapter. Simple molecular structure of chapter 9. Okay, this is the final phase online lesson next Monday. So Tuesday will come. All of you will come back, right? It's 29th, is it? Yes, 29th. This is the day where you come back. So I do hope we will have an easy life. I know that this topic is rather abstract. Just try your best to do this. It seems the easiest start to all of you. Okay. See you guys. It's time to take a break. Bye bye.